Hello everyone. Today we're going to be talking about parabolas, specifically creating them through a directrix and a focus and or a vertex. Now this is a pretty interesting topic as it allows us to draw parabolas without the use of algebra because a parabola is defined as the graph that it makes when a point on the graph is equidistant between a point called the focus and the line, the directrix. So first of all, with that, I think we need to create a formula given a directrix and a focus. But first of all, let's see what a graph of a parabola actually looks like. So a standard parabola would be this U shape drawn. And so what we're going to do is first set up an arbitrary axis of x and y just to define where we are within the coordinate plane. So first of all, let's with this parabola that we've drawn, let's draw the directrix under the parabola, making sure that when we draw the focus that we draw at equidistance from the vertex from the directrix to the vertex and from the vertex to the focus. This ensures that we do create a semi-accurate graph. So that means the focus goes just a little bit over or a little bit above the vertex, and it has to line up with it. So there it is, and we're going to label that point A, B. Now we're going to take an arbitrary point along the line of the parabola, and we're going to call that point x, y, just because of the arbitrary graph that we've already made. So what we're going to do is we're going to define what x and y are based on what a and b is, and what the directrix is, which we're going to call the line y is equal to k. So with this, we need to take the point, and we're going to extend it to the vertex, and then we're going to take another line from the arbitrary point that we've created, and we're going to drop it down to the directrix. This will create a perpendicular line that's not really important, but that's just a key feature of this. That is the maximum distance, of course, and we're going to use that distance as the one that's equidistant to the vertex. So now this, let's set up distances, since I have been saying that these two values are equal. So we're going to say that the distance from y to k it is going to be defined as the distance. Now the way I've defined a parabola is so based off this definition, the parabola is allowed to be defined in negative areas, since distance does not depend on negativity. It only depends upon the absolute distance from one point to another. So we're going to find the distance from the parabola's arbitrary point to the line as y minus k. In order to fix the different to make sure it's positive, we're going to say it's y minus k squared. And because this distance, we want to square root it. Do not simplify the square root and square just yet. So now on the other side, we need to set this equal to the distance between the focus and the arbitrary point on the parabola. We just plug into the distance formula, and we have x minus a squared plus y minus b squared, and that's all square rooted. So now we're going to set these two quantities equal. That is, the square root of y minus k quantity squared is equal to the square root of x minus a quantity squared plus y minus b quantity squared. So now we're going to square both sides to get rid of the square root sign. We're left with y minus k squared is equal to x minus a squared plus y minus b squared. Now we're not going to do anything with the x minus a squared, but we are going to do things with the y minus k squared and the y minus b squared, because we want to be able to find an equation that is that is explicit to only y and x to make it a function. So what we're going to do is we're going to expand the y minus k, which is y squared minus 2ky plus x squared, and we're going to expand the y minus b squared, which is just the same thing with the k's being replaced as b's. So y squared minus 2by plus b squared. So now what we want to do is we're going to move the y's to one side so we can get that y isolated so we can define this function. So now what we're going to do is we're going to subtract over the k squared from the left side and put it with the b squared, and then we're going to have the negative ky stay over on the left side, and we're going to subtract negative 2by over. Now what we're going to do is we're going to pull out a 2y from both sides since this is a common factor, and so what's left is b minus k. So now we have 2y times the quantity b minus k is equal to x minus a quantity squared plus b squared minus k squared. So now we need to isolate y. So we divide both sides by 2 times b minus k. And from there we get x minus a squared over 2 times b minus k plus b squared minus k squared over 2b minus k. So now what's important about this idea of b squared minus k squared is, if anybody noticed this is actually a difference of two squares. So now we can factor b squared minus k squared into b minus k times the quantity b minus k times the quantity of b plus k. As you can tell, the b minus k's do cancel from the top and bottom, and we're left with the grand old equation y is equal to x minus a quantity squared over 2 times b minus k plus b plus k over 2. This is the equation of the parabola we've created from the postulates that we were given at the parabola's equidistance from directrix and a focus. So now we need to make sure it is defined for other parabolas as well, specifically the ones that point sideways. The same thing applies here. This is, although it's one that opens up to the right or to the left, they're not going to matter. Just want to show you that as well, because the same idea applies. It's just a shifted graph. So we had the picture here. We have the arbitrary x and y axis, and we have our arbitrary parabola with our line x is equal k this time, but keeping the points a comma b and x comma y as our equations. Now although this particular graph is not a function because it fails the vertical line test, we can define this. We can define this as an equation. It's just not a function. We can still go ahead and define it though, which we are going to do. We're going to apply the same principles. So the distance from x to k, or the y's to k, because it is, or the x value to the line x is equal to k. Since this is a vertical distance, you only need the square root of x minus k squared, as we did with the first one. And on the right side, it's going to be about the same. It's going to be the square root of x minus k squared plus y minus b squared. Although this is the same, we're going to manipulate it a different way. Since both sides do contain an x, we want to get an x on the left side, so we're going to go ahead and square both sides. So now we have x minus k squared is equal to x minus a squared plus y minus b squared. Since y minus b squared is not going to change if we expand it or not, we're just going to keep it y minus b quantity squared, as we did in the first one with x minus a squared. But this time we're going to expand that one in x minus k squared, and we do that. We get x squared minus 2xk plus k squared is equal to x squared minus 2ax plus a squared plus the y minus b quantity squared. So that leaves us with doing the same thing that we did in the first one. We cancel out the x squares. The kx can go over to the right side, and the 2ax will be brought over to the left side, and we factor out a 2x, and we get a minus k is equal to all of this. And we're going to just go ahead and say that a squared minus x squared is equal to a minus k quantity a minus k times the quantity of a plus k. Simplify from there, we get x is equal to y minus b squared over 2a minus k plus a plus k over 2. So you see here it's a very similar equation, not identical, with just the x and y's flipped and the a's and b's flipped. So as you can see, the idea of a parabola being defined as points equidistant from a point and a line, those being the focus and the directrix, we're able to define what these functions are in terms of those arbitrary constants we're allowed to put under those. Those numbers can be anything, just as long as they do create a parabola. That is all for today. We're just proving and creating different equations for parabolas. The next video we will be doing examples with just plugging numbers in. Thank you.